start your session. Let's see that it's working. אוקיי. I'm recording, great. אז שלום לכולם, ברוכים הבאים. אנחנו בעוד מיטאפ, 21 בדצמבר, אני רוצה לעבור על כל מיני דברים, יש כמה הודעות גדולות למי ששמע ולמי שלא, אז תכף אני אעדכן, ואחר כך נעבור לסשן של קווין שאני אציג אותו בהמשך. אז השקף הזה, זה כנראה לא כנראה, זה פעם אחרונה שאני אראה לכם אותו. פס בעצם הודיעו על סגירה של הארגון, הארגון סיים את תפקידו בעולם, שזה מאוד עצוב. פס קיימים כבר הרבה מאוד שנים, יותר מ-20 שנה לדעתי, אני לא זוכר בדיוק כמה, באיזה שנה הם הוקמו.
20
בדיוק. 20 בדיוק? 20 בדיוק, תודה רונן.
1999.
אז 21 למעשה. שירתו את הקהילה בהרבה אופנים, בהרבה תחומים, בהרבה דרכים, באמת כבר הרבה מאוד שנים, נתנו המון לקהילה הזאת. הרבה מאוד מהאירועים, גם המיטאפ הזה למעשה, בין היתר אנחנו גם חברים בפס, מה שנקרא פס לוקל גרופ, ויש וירטואל גרופס, למי שהיה פה קודם בשיחה עם רונן, יש SQL Saturday שהיה פה בישראל כמה פעמים, וכנראה כבר לא יהיה לפחות לא תחת השם הזה, ועוד הרבה אירועים, פס סאמיט כמובן, המון חומרים ותכנים באתר של פס, באמת המון דברים. ארגון ללא כוונות רווח שבא לעשות טוב ולקדם את הקהילה, אבל השנה הייתה שנה מאוד קשה בגלל הקורונה והמעבר של פס סאמיט לאירוע וירטואלי, ועוד כל מיני סיבות, היו הרבה רעש ברשת, הרבה אנשים כתבו כל מיני דברים, אני לא אכנס עכשיו לדיון הזה כי זה לא המקום, אבל בסופו של דבר הם הודיעו על זה שהם לא יכולים להמשיך להתקיים, בעצם אחרי השנה הזאת, והם סוגרים רשמית את השרתים ואת כל הפעילות ב-15 לינואר, והם הודיעו שעד ה-15 לינואר, כל מי שרוצה, יש לכם הזדמנות להיכנס בעצם לאתר של פס, לצפות, להוריד מה שאפשר, יש המון חומרים, המון סשנים מוקלטים, באמת בכמויות, מכל השנים שפס קיימת, יש את כל האתרים של ה-Virtual Groups, לפי נושאים, לפי DBA ו-Cloud ומה שאתם לא רוצים, בכולם יש ארכייב של המון סשנים, אני לא יודע, לא בדקתי, אני לא יודע מה אפשר להוריד ומה אפשר רק לצפות, כל אחד שיכנס ויבדוק ויראה, ומי שרוצה ויכול להוריד שיוריד, כי כמו שהם הודיעו ב-15 לינואר, הם פשוט סוגרים הכל, וכל התכנים האלה כבר לא יהיו קיימים. אז מבחינה הזאת, לכו תבדקו, תסתכלו, תראו מה יש, ותעשו עם זה מה שאתם מוצאים לנכון. אנחנו כמיטאפ כמובן, נמשיך להתקיים, זאת אומרת, נכון שהיינו חברים בפס וזה, אבל זה לא השפיע יותר מדי על הפעילות שלנו, חוץ מזה שהלוגו כבר לא יופיע, והשקף הזה כבר לא יופיע, והאתר לא קיים, אז אנחנו נמשיך כמובן להתקיים ולעשות מה שאנחנו עושים כרגיל, והמטרה גם להרחיב את הפעילות שלנו בקומיוניטי המקומית בישראל, נדבר על זה גם בהזדמנות אחרת אולי, על כל מיני כיוונים ורעיונות למה אנחנו רוצים ויכולים לעשות פה. אבל זה חדשות מאוד גדולות ומשמעותיות בכל העולם, בקומיוניטי שלנו של דאטה פלטפורם, שנוגע לכולנו, אז מי שלא ידע אז כדאי לדעת. זה לגבי פס. אני רוצה ככה להזכיר שוב בזריזות את כל הערוצים שבהם אנחנו פועלים נכון להיום, שבהם אתם יכולים בעצם להיעזר. אז קודם כל האתר שלנו קיים, המיטאפ שלנו קיים באתר של מיטאפ, יש פה את הלינק ואת ה-QR קוד, מי שרוצה, מי שעדיין אין לו ולא שם, רוצה לצלם וכולי, אז תצטרפו, תקבלו עדכונים על כל האירועים שאנחנו עושים. יש קבוצה בפייסבוק, מאוד פעילה, לא זוכר כמה חברים יש בה, אבל יש הרבה, 2000 ומשהו, לא זוכר בדיוק. הרבה דיונים מקצועיים, מחפשי עבודה, מחפשי עובדים וכולי, כל מה שקשור לדאטה פלטפורם קומיוניטי, אז מוזמנים גם להצטרף לזה כמובן. יש לנו את הערוץ יוטיוב, כל הסשנים במיטאפים מוקלטים ועולים לשם, אז אתם יכולים גם ללכת לשם ולצפות בכל הארכייב שכבר יש לא מעט, והולך ומצטבר, וגם לעשות שם סאבסקרייב, ואז לקבל עדכון כל פעם שעולה לשם משהו חדש. רדיו SQL Server, אני ואיתן, יש גרסה בעברית, יש גרסה באנגלית, יש לכם פה את הלינק לגרסה בעברית, פעם בחודש אנחנו מוצאים תוכנית, כל מה שקשור ל-SQL Server, מדי פעם מראיינים אורחים באולפן, מדברים על פרויקטים שעשינו, על פיצ'רים חדשים שיוצאים, על אירועים בקהילה, כל מה שקשור ל-SQL Server, בפורמט של פודקאסט, למי שזה מתאים לו, למי שאוהב. יש לנו קבוצת וואטסאפ, שקראנו לה מומחים של מדרה, זה כבר מזמן לא רק המומחים של מדרה, זה שם 200 ומשהו אנשים, הרבה מאוד אנשים נמצאים שם, אני בטוח שאתם יודע, שחלקכם גם שם, אז מוזמנים... אם אפשר לעשות מיוט, אני אעשה מיוט.
זה מוקלט.
אני
אמרתי נראה אם שווה.
זהו, יופי. אז קבוצת וואטסאפ למטרת דיונים מקצועיים, מאוד אינסטנט. אם יש לכם איזושהי שאלה, אתם צריכים עזרה, תבואו לשם, תכתבו, יש שם 200 ומשהו אנשים שישמחו לעזור, יש שם דיונים מקצועיים מאוד מעניינים כל הזמן, אז מוזמנים להצטרף לשם מי שעדיין לא נמצא, יש פה את הלינק להצטרף. ועוד משהו שאנחנו במדרה עושים, כשירות לקהילה, בגיטהאב, העלינו כבר מזמן, רפוזיטורי שנקרא מדרה טולבוקס, כל הסקריפטים, כל הדברים שאנחנו מפתחים, כל מיני סקריפטים שימושיים ופתרונות כאלה ואחרים סביב המייקרוסופט דאטה פלטפורם, נמצא שם, אופן סורס, מוזמנים להשתמש, לתרום, לקחת חלק גם מה שיש שם, אנחנו מעלים שם דברים חדשים כל הזמן, אז מוזמנים גם לשם להצטרף, וזהו, זה מבחינת ערוצים, ושוב, המטרה היא להרחיב, יש פה המון דברים שאנחנו עושים, ושבאמת אפשר כולנו להיעזר בהם ולתרום, אז מוזמנים לקחת חלק. מבחינת אירועים, הפעם זה יהיה קצר, היו המון אירועים, כמובן שכולם וירטואליים, כולם אונליין, בתקופה האחרונה, עכשיו קצת נרגע, אני רוצה להזכיר את המיטאפ האחרון שאנחנו עשינו, על SQL Server Internals ו-Architecture, שהיה מאוד מעניין, כנסו לפה, יש שם את הלינק להוריד את החומרים, והלינק להקלטה, למי שלא היה, הכל נמצא שם. אין לי כרגע אירועים מעניינים, גדולים, משמעותיים שאני רוצה לפרסם, גם במיטאפ שלנו, כרגע עוד לא הספקתי לפרסם, זה פשוט נורא עמוס בתקופה האחרונה, לא הספקתי עדיין, אבל יש הרבה דברים בקנה. אז בקרוב אני אפרסם עוד, ויש עוד מיטאפים מאוד מעניינים שהולכים לבוא בקרוב, אז יהיו עוד הרבה דברים, ואני אעדכן בהמשך. אבל זהו, אני רוצה לעבור, אלא אם כן יש שאלות או משהו, לפני, שעוברים לקווין, מישהו משהו? Okay, so I'm switching to English now. Let me introduce Kevin Fiesel, Data Platform MVP from North Carolina. He speaks in many events. He used to travel and speaks in many events all over the world, but now it's from his home, but still speaks in many events. He blogs mainly at curatedSQL.com, right? Even wrote a book about Polybase, I think.
Yeah,
correct.
That is correct.
And an expert in SQL Server, machine learning services, but many other things. Today he's going to talk about SQL Server Machine Learning Services, how to develop a solution using this platform. And I think that's it. It's on to you. Please share your screen.
Sure.
And let's start. All right.
Everything good here?
Yeah. If you have any questions, by the way, during the session, feel free to write them in the chat. Kevin will monitor it by himself, or I will do it also. We'll have also time for a Q&A at the end. So feel free to ask any questions you have.
Exactly. Yeah. So any questions, I will stop a few times. If I'm speaking too fast at any point, also, please just let me know. So welcome to developing a solution with SQL Server Machine Learning Services. As mentioned, my name is Kevin Fiesel. I am a Microsoft Data Platform MVP out of Durham, North Carolina. Run a predictive analytics team, and as also mentioned, a blog is Curated SQL, where I try to find and link to 5 to 10 interesting posts per day anywhere across the entire data platform space. So that's curatedsql.com. Machine Learning Services was originally called SQL Server R Services when it was released with SQL Server 2016. The idea there was to be able to call out to an external R process, run some code over there, and expose the results natively within SQL Server as a result set. In SQL Server 2017, we got the additional benefit of running Python code. So with the additional language comes a name change to SQL Server Machine Learning Services. In 2019, Microsoft added support for Java, and this year they've open sourced the entire extensibility framework, with the idea being that the community can add additional languages as well, should the desire be there. I'm going to focus today on the R and Python side of things. Java is a bit different, and who knows what the future will bring and what additional languages will be there. So let's stick to R and Python. I'll introduce you to SQL Server Machine Learning Services and give you an idea of when it will fit, as well as cases where it will not fit. So if you are running a machine learning project today, I'll give you an idea of whether this might actually be a reasonable platform. We'll show briefly how to install and configure machine learning services, but what I really want to get into is how would I deploy packages, develop code against it, and deploy that code. And that's what we're going to do today. So let's start off.
Kevin?
Yes.
One small question before you start. It's called Machine Learning Services, but it's actually the ability to run external scripts, right? So Machine Learning Services, the name implies the use case, not the technical capabilities, correct?
Correct. Yes. So you can do things other than machine learning with machine learning services. You can run any R or Python code. And actually, it's a good point where, for example, something you can do pretty easily in both R and Python is scrape web pages. That's not a machine learning task by itself, but it is something that's, there are native packages available in both languages. And there have been cases where I've just needed to scrape a web page and get data. There was no API available. There was no JSON feed available. And I was able just to run machine learning services, execute some Python code, scrape that web page, get the data back that I needed, and move on, rather than having to build out applications which did this work regularly. So a little bit of a weird edge case there, but yeah, you're absolutely not limited to just running data science operations. You can also do anything that's available in those languages.
Yeah, thanks.
And the way that it works is that for R, we have our SQL Server process, that's SQL Server.exe. When I want to execute that external script, the reason they call it an external script is that we're not running the R code or the Python code inside of SQL Server. Instead, we have a Launchpad process. The Launchpad process is essentially our way of connecting out to R or Python's executable. So we open up that process. We execute, in this case, the R terminal, run whatever code we need to run, and then there's a DLL that will allow us to feed data back into SQL Server using the BXL server. So that's the process that will take that R result set, translate it back into what SQL Server needs, and pass the data back to the database engine. And then we get a result set back in SQL Server that is just looking like any other result set. For Python, the process is almost exactly the same, except that we have a Python executable instead of our term. So in both cases, we have this Launchpad that is the bridge between our SQL Server and the remote code. The nice part there is if that remote code causes, say, Python to crash, it's not going to bring down SQL Server. So there is separation between the two. One of the biggest benefits of machine learning services is the capability of using native scoring. There are 5 total algorithms that allow for native scoring, and these are fairly simplistic algorithms. They'll get you some of the way there, but if you have a problem that maps well to one of these algorithms, the benefit to this native scoring is that it is incredibly fast. The code that you write, that R code or that Python code that you write, you can essentially call it in production without having to execute R or Python itself. The algorithms here are implemented as C++ libraries, as I recall, and so we don't have to load R or Python. What this means is that it's about 1 to 2 orders of magnitude faster than if we had to go out to R or to Python. So we're able to get compiled code. We're able to run this process without having to go out to an external process. And we're able to get, in my testing, I was generating 10 to 20,000 records per second. In my production scenario, we don't generate quite as many per second as that, but we do get thousands per second. So it's a lot of predictions that we can generate per second versus, say, 30 to 40 predictions per second at most if I'm going out to R and Python. Maybe I can get up to 100, 150 for this production process, but we're talking at least 10 times as much. That's not too bad. It is, in fact, I think one of the biggest benefits to using machine learning services. The gist of this, let's see. So we have a question. What is the host process to execute the C++ functionality if the platform is not python.exe? So this is, let me see if I remember right. This is actually executed from within the SQL Server executable. The libraries are loaded and they are run internally. So it's the precompiled code for those libraries. And what happens is that they receive the model that you've generated, but that code has been precompiled. So let's see. You can use it not only get to data, but also pass data as well. Yes, we will show examples of sending along data as part of today's plan. So it's like an external procedure in Oracle, more or less as an out of process. I'm not familiar enough with Oracle to tell you for sure, but it is out of process, yes. What benefit of that is, like I said, if there's a failure on the other side, it's not going to take down SQL Server. The downside is it's hard to tell what's happening. Essentially, as this is running, all you get is a wait state that says, okay, the satellite service is running. We're basically waiting for a response. As far as SQL Server knows, it's still going, but I don't know when it's going to finish. I don't know how far it is. We don't get that diagnostic information while it's running. Limor says, I would like to know when exactly is the best scenario. When is it optimal to use ML services inside the database instead of Kubernetes cluster or CPU scaled solutions? I will get to that. Okay. By the way, one thing I want to point out here is that this is mostly around the development side. If you're interested in something that's more on the production side, the database administration side, csmore.info/on/ML services. I have a separate talk that is all about our experiences with machine learning services in production. So this is more of the development side. What do I need to do to get a package deployed? So going to Limor's question, what works well? Well, there are a few different scenarios that make sense to use machine learning services. If your input data is in SQL Server, then it's going to make a lot of sense. I don't have to move the data around. If I have to pull all of the data into SQL Server and I don't actually store it there, this doesn't make much sense. Just have your own external Python or R servers. If I have batch processes, this is a good thing. The startup for one of these calls can range anywhere from about 1 second to, I've seen, 5 to 7 seconds. There's a pretty large variance in how long it takes for these warm-up activities before it actually begins processing anything. So if I have something that takes, say, an hour to run, adding an extra 1 to 5 seconds, not going to be concerned. If I have something that I need to be done within 200 milliseconds, I would not use machine learning services for this. So we had one project where it fit all of the other requirements, but we needed responses in tens of milliseconds or 100 milliseconds. This was going to be a near real-time API, and we could not get results that fast. So we ended up having to deploy it out separately as a web service. Now, the case where it can be extremely fast, where we don't have to worry about that startup, is if we're able to use native scoring with that predict operator. Because we're not opening up a separate process, there's none of that startup time. So we're able to just execute the predictions immediately. So if we had the type of problem that could be solved with one of those native scored algorithms, we would have been able to use this solution. But in that scenario, we didn't. One of the weirder things about this is that as my team started working with machine learning services, we realized the story for interacting with R code from .NET is not very good. There is a package called r.net. It's a NuGet package that is available, and we tried it out. We tried working with it. It just did not meet our needs at all. So it turned out to be easier to access through the database, through our very expensive SQL Server, to have an R machine integrate with a .NET machine. That turned out to be way easier, way more effective for us. May not work for everybody in the sense that, you know, we need SQL Server to act as the intermediary, but we had that SQL Server instance available and decided we were going to put it through its paces. Now, what doesn't work well? If you need singleton near real-time predictions, like I needed in that one case, and you cannot use native scoring, then this will not work for you. There is that startup time ranging from 1 to 5 seconds. And if you add that to every call, it slows things down a lot. If you have to bring in all of your data from somewhere else, you know, that's an indication that maybe you don't want to run this in SQL Server. And also, R code and Python code tends to be fairly CPU intensive. They tend to do a lot of work. So if your SQL Server instance is already nearing 100% CPU, you might not want to use machine learning services to execute code. You can still use native scoring predict. That doesn't go out and execute R and Python code and is very fast, very CPU efficient. So you can score a model. But if you are talking about training models, if you're talking about generating predictions from within R or Python, make sure you have enough CPU overhead available. When we first launched a project, we were building neural networks in machine learning services. And I had redlined my SQL Server instance for 3 days straight at 100% CPU. And the database administrators eventually reached out because they kept getting paged because CPU was literally 100% for 3 days straight. And they were trying to figure out what was going on here. I'm like, oh, it's okay. I'm just building neural networks. Nothing to be afraid of. I got more CPU cores after that, so that was cool. Very briefly on Azure SQL Edge. Azure SQL Edge it's an interesting new product that is available to us and is essentially SQL Server on something like a Raspberry Pi, on a small IoT form factor. It offers support for something called ONNX, the Open Neural Network Exchange. The idea here is that I would build a neural network using TensorFlow, Caffe, PyTorch, CNTK, whatever process I use. I could convert it to this open neural network format. And from there, I can import that into Azure SQL Edge and natively predict against that neural network. This is something I'm very excited about. If I have this in my current SQL servers in production, I can do basically take all of those projects that I had to say not run in machine learning services because they'd be too slow. I could run them all in here because we can do native scoring against neural networks. That's a pretty big deal. Does not currently support SQL Server 2019. It's only on this Azure SQL Edge. So hopefully that extends out to the box product in the next version, but we'll see. Installation is pretty straightforward. We say, hey, I want to start a new installation or add to an existing installation. There are two options. This is probably the most confusing part. And before I get to that, Yariv has a question. Why is it different from downloading the Onyx file to the edge and querying it using Python directly? The biggest difference is that if I'm going to take a drink of water. That will help me answer my question. Okay, if I execute this using Python directly, then I could take those inputs, I can get the outputs, and you're right, I'll get back, like it'll behave as I would expect. The biggest difference is that if I have a lot of data in SQL Server, so let's say that I'm collecting telemetry data for different devices, and I'm collecting this telemetry data, maybe current temperature of the device, current number of rotations per minute, and I've got a model based off of these input data points that will tell me whether or not there's an issue with my machine. So if I'm taking this data in, as I store it in SQL Server, I can also run this predict function and write the new prediction outputs to the same result set. If I have that table, I might even have something like, say, a job that is regularly looking, do I have any errors? Or my stored procedure that writes telemetry output to SQL Server could also then send a message out saying that, hey, there's an issue here. Basically, it cuts out the need for an additional step. So if I have everything already running through SQL Server, I can score these predictions and I can act on it without having to leave SQL Server and open up Python. But if you don't have SQL Server and you just want to execute this in Python, then yes, you could do that from Python. So it holds the model, but not the data, and you fill it with data and execute. Correct. Basically, I'll show you the examples in a bit, but we have the model, which will be binary. And we have the data that's going to be fed into the model. All of that stuff is going to be within SQL Server itself. The results of it will also be in SQL Server itself. And we execute that binary. The code that executes that binary is in a DLL that comes with SQL Server. So for our native scoring, those DLLs come with SQL Server on premises. With Onyx, that comes with Azure SQL Edge. That's a linked library over there because that's on Linux. Coming back here to Machine Learning Services to select. We have two major options, and this can be a little confusing, but basically almost all of the time you want the ones in the box. Machine Learning Services in database. That's all of the behavior that I've been describing so far. The one below, Machine Learning Server Standalone, is specifically if you want a server that is for Python or a server that is for R, and you do not have SQL Server on that machine, and that machine has been licensed. So, for example, let's say you have a whole ESX host, and the whole host is licensed for SQL Server. You have some extra cores available, and you want to spin up a VM on there that is just to run Microsoft R Server or Microsoft Python Server. You can do that. Generally, though, the use case we're looking at here is going to be, I want to integrate R and Python with my data, with my database. And that'll be the first option. After we install, we say, okay, execute spconfigure external scripts enabled, turn that on and reconfigure. Now I've got Machine Learning Services ready to go. I restart the Launchpad service. And I would also recommend restarting the database engine as well. So we restart that Launchpad, we restart the database engine, and we're ready to go. Administration portion is complete. Now it's time for the data scientists to take over and do their work. The first thing that we're going to want to do is install some third-party packages. There are a few different techniques that we have for the installation of third-party packages using R or Python. I'm going to give you 3 techniques, and I'll tell you when each one makes sense. The first one is sqlmlutils. So sqlmlutils is a utility that they've got one version for Python, one version for R. And this is a way to install that code remotely. I consider this the best way for working with R for SQL Server 2017 and 2019, and for Python in SQL Server 2019. This does not support R in 2016, does not support Python in 2017. So for these editions, these languages, this is the best way to do it. It's something that you can automate, something you could make as part of a deployment process. Let's say you don't have sqlmlutils, or for some reason it won't work. And there are reasons. As long as you have administrative access to this machine, you can use the R console or the Python executable and install. So with the R console, we would run R term, and the install.packages function will allow me to install a package on a remote instance. If I'm in the Python console, I can run pip install, and that will allow me to install a package there. You can also install, say, local packages, local R packages that you've zipped up, or Python packages you've put into wheel format. So if you have your own custom deployed packages, you can push them out this way as well. The third option is create external library. This requires some permissions, like grant, alter any external library, and will allow you to install a package from a zip file. So this is the third technique. And in this case, what I have is I've put a zip file with an R package onto the local disk of that SQL Server instance. So this may be on a server that I've put sql/temp/Benford analysis onto there. In this case, I don't have the permission granted to me to alter any external library. So I got back an error that said, hey, you don't have the permission. That permission has been denied. If you have the permissions, then what will happen is it will create that external library specifically for your user account. The security of machine learning services has changed. There's security concepts for 2016 and 2017. There's a separate security concept for 2019. The 2019 security concept is to split out personal use versus group use or public use, and to emphasize that personal use. So the idea here is that my data scientist team, I may have people running different versions of packages, and they want to test things out. So for example, let's say we're using this Benford analysis package, and there's a new version of it that's come out. So one of my team members may try to upgrade their version of the package, test our code and make sure that it still works. And then if everything looks right, then we could upgrade the public version of it. That's kind of the feeling that they wanted you to get toward. I think it adds a layer of complication to the problem, but I can see where they're coming from. And I will admit that in my case, I'm not working with a lot of different data science teams across a large organization. I've got one predictive analytics team, and we kind of go one direction. So some of the finer grained functionality we don't really care about, because we've essentially got one version of a package we're going to develop against. But in a larger organization where you have a lot of different teams and it's hard to get everyone on board, the options are available here.
I can tell you that we work with some customers where we had issues with the security changes in SQL Server 2019. It's quite complicated.
Oh yeah, we had issues as well where things that our workflow had to change radically as a result of it. And the changes are generally for the better in the sense that they are much more secure. So to give you an example, prior to 2019, I could, with no additional permissions, access a local hard drive with Python or R. Well, what that essentially means is that anybody, say if somebody were to gain access to my SQL Server instance, they could execute Python and R scripts. So they could execute any Python script, which would also give them access to the whole machine using the rights of whatever account is running the SQL Server Launchpad service. And that would, in effect, give you quite a bit of access on the machine. So as of 2019, they locked that down. You can only read from a temporary directory that is located in a subdirectory in a folder in a folder in a folder, and you only get access to that. And after your session ends, you don't get access to it anymore. You get a new folder. Well, that changed some of the behavior we had where we were reading stuff off of disk to load projects. We had to change that completely. And Ronan's right. It's the same issues with CLR. So that's why they changed. They changed to this containerized model, which is different from Docker containers, but basically securing every session in its own little bubble and really locking down the permissions available. But for those of us who were using machine learning services, we were used to behavior in a certain way, and it completely changed. So yeah, that was fun. So use sqlmlutils in general if you can. This is the best route. If you can't, if there's an error or there's a reason why you cannot, the console is good for complex packages. So I'll give you an example of this. 2 examples. Example number 1, I have Keras here. I had to install Keras and TensorFlow using the Python console. Couldn't do it directly through machine learning services, especially Keras in R. If there's anything where installation requires interactivity, the sqlmlutils package will not work for you. The other example that I have, we had one project that had a large neural network, and we wanted a way to deploy this neural network. And like Guy mentioned, well, the security model changed in 2019. Prior to 2019, essentially, we could read this from disk. So we would have the binary file containing this neural network model on disk, and we could read it and we could process based off of that. 2019 comes around, we can't do that anymore. So we had to put it into the package itself. So we have this R package that is normally about 600 kilobytes that turned into about 65 megabytes. And we tried to deploy this using sqlmlutils, and we're getting errors. I still have a GitHub issue open around that. Never got a solution for it. So instead, what we have to do is go to the console, pull that zip file, that binary package local to my SQL Server instance, and run install.packages locally. That'll work fine. So console is more like a fallback option. And create external library, custom packages, or cases where you want your data scientists to have different versions of packages. Look at a quick demo in R. So here we are in RStudio, and this is a slightly older version of sqlmlutils. So the version that I had required this R ODBC extension. I believe the newest version no longer requires this, which is good because that package was actually deprecated. So we install the sqlmlutils library, and I'll just run this just to make sure that it's installed. Okay, it was already built. Now, if I want to connect to a database, this is in RStudio. This is a client. I can connect to a remote SQL Server instance. It doesn't have to be a local database. I use my ODBC driver. So this is the latest ODBC driver for SQL Server. And I can connect to a server in a database. And by default, this is going to connect using Windows authentication. If I want to use SQL authentication, well, I can use UID and password. So here's a case where I have it running on localhost on a named instance, or excuse me, on a separate port. That was my Docker container version. But yeah, if I want to run from a different server altogether, I absolutely can. And that means I can also make this as part of a continuous deployment script where code changes, we take that binary package, we can push it out to SQL Server. So let's make that connection. And if I go over here, look at environment, I have my DB connection, which is currently pointing at localhost, the expense reports. To install a package in R, there's install.packages. For sqlmlutils, there's sql_install.packages. We say, here are the packages I want you to install, and send in a list of packages. The scope can be public or private. So public, install for everybody, and you have to be an administrator to do this. Private, you install for yourself. The repository, where I want to get this from, Case University in Northern Ohio. I can install this data table package. Because it's already installed, what'll happen is that this will come back and eventually say, hey, you already have this installed, but there's a newer version out there. So it does not automatically upgrade packages. And with R, upgrading packages is not trivial. The best method I have for upgrading packages is to remove them and reinstall them. For Python, there is a flag where you can say, go ahead and update the package. So this takes a moment to run. I'm not going to run through all of these right now because of that. But we can see in this next line, I can have multiple packages that I'd like to install. I can rerun this process over and over. And if I have the latest version, all it's going to say is, oh, you already have the latest version, so I don't need to do any work. If I don't have the latest version, it says, hey, you don't have the latest version, but I'm still not going to do any work. It's only if I don't have the package at all that it does work. So here we go. It's already installed, but the version is older than what's available in the repo. So I could upgrade to the newer version if I wanted to. If I remove a package, it's remove.packages, SQL_remove.packages. I can see which packages are currently installed by running SQL_installed.packages. So this allows me to select certain fields, and it focuses specifically on the R packages. So if I have R packages and Python packages, this will just show me the R code. And then I can use view to create a grid of the results. So this is a little bit slow, but it will eventually give me results back. While we're waiting for that, installing our own package, I don't have a repo. It's not up in CRAN. It's not available to anybody. This is private code, company code. So my package is a specific location of, in this case, a zip file. So I'll take that and I can run SQL install.packages, execute this script. I can also remove the package just as easily. So I'm calling this expense reports R, and hence it will have that name in packages, and then I'll be able to remove it after the fact. So that's installation of packages using R. If I switch over to here, I can see doing it in Python. The code is very similar. I'm not going to execute any of this right now, but basically we have the sqlmlutils library. We import that namespace. We create the SQL Python executor off of our connection. So our connection string, like this case, would be localhost expense reports using Windows authentication, or localhost on port 52433 expense reports using some username and password, SQL authentication. So we have our connection. We build out a package manager. I have my Python executor if I wanted to just run Python code on here. My package manager allows me to install. So I can install, for example, the Werkzeug and term color packages. Here I have upgrade equals true. So the Python version of sqlmlutils has an easy upgrade option. The R version, last time I checked, does not. I can also set the scope, again, public or private. By default, if I don't set a scope, it will be just my account, my private scope, unless I am sysadmin. If I'm a sysadmin, then it will set it to public by default. I can also install and uninstall local wheel packages. So here I have a wheel file, and I can install it in the public scope, or I could remove it as well. Looks like this finished up, so I could say view, and we can see all of the different packages that I've installed using this. So I'm going to open up this lib path. Let's expand this a little bit, because I want to point out this location here, specifically where it says external libraries 12.1.1. These are packages that I have installed. If I scroll down near the bottom, I have program data, my MSSQL Server R library. These are things that were installed by default by SQL Server. So the packages that I've installed don't go in the same directory. They go instead into a different library. These numbers at the end probably have meaning, but I don't know exactly what the meaning is. It might be per user. It might be, I think this might actually be public packages in type R, but don't quote me on that. So basically, they go into their own separate folders. That way, if I have my version of Whisker and you have your version of Whisker, they'll be in different folders. And then we have the general version of Whisker, which is available in this folder for everybody. And we have the graphics library that nobody else gets to touch, because that one's installed in a separate location where Machine Learning Services gets read access but doesn't get to write to it. So basically, these packages are stored in different locations based on who does the work. We've spent some time installing the packages that we need. Now let's see how to execute scripts. There is a built-in stored procedure, sp-execute external script. And if you're familiar with sp-execute SQL, this is going to be quite familiar to you. So we have, I need to get rid of that line. Okay, so we have sp-execute external script. The language is R. The script says to print out hello world. So we're going to run this. It'll run using the R launchpad. It'll return us back hello world on the console, essentially on the console line. So the in Management Studio, that'll be the text line that comes back. In Azure Data Studio, if I come over here and just say, and run this, assuming that my Launchpad service is up, then what I will get back is a print statement. So we're going to see if my Launchpad service is up. Here we go. Here's our output, hello. So external script took a while to start up, took a while to wake up here. Like I said, there is a startup time, even to do something as incredibly simplistic as print hello. So it's not necessarily based on how complex this script is. It's just today it's being kind of slow to me. All right, so I want to do this in Python instead. Well, this radically changes because now instead of language equals R, language is now Python. Let's say I want to have an actual script. I want to do something more than just printing hello world. So our language is still R back in here. I can pass in a variable, remote command. So I could create remote command separately, and I can pass it into the script. That way I could use dynamic SQL to generate what that remote command should look like. I can send in data. my input data set will be called input underscore data underscore 1 as the variable. And this is the T-SQL query that should run in order to get this data. One thing I want to point out is that you can't use table types, table variables to retrieve data in here because the scope will be different. You can use temp tables, as I recall. You can definitely use global temp tables, and you can definitely use permanent tables like we have here. So I'm going to say select some columns from some table, and I'm going to call that data frame training data. So in R, I'll refer to this as training data. If this was Python, it'd be a pandas data frame called training data. So even though the variable name is ugly, input underscore data underscore 1, the way I reference it in R and Python, if I set this, will be whatever nice name I set. I can have input and output parameters as well. So my params, trained model is a var binary max output. What this means is I expect to get back out a variable called trained model, and it will be of type var binary max. It'll be probably a serialized model. And then I define what those parameters look like and how they map outside of this call after the params. So again, if you're familiar with SP execute SQL, you're familiar with the params and the mapping sections. The input data and the language is a little bit different, but not too crazy. Let's build a project. Giving you the brief overview, we're gonna do some fun stuff now. So here's the use case. Our organization figured out that several employees were performing expense fraud. Basically, employees were allowed to submit expense reports of up to $40 without requiring any receipts. It was on the honor system. But anything above $40, they needed to include a receipt. Now, several employees began abusing that system and might spend $10 for food, but then submit $40 as the expense. So management wants to get an idea of how much we think that employees took above and beyond the expected amounts. We have a good feeling of who those people were. They admitted it, and we have a good feeling of when it happened. So we want to know what the rough cost was to the organization. So what we're going to do is some early data investigation. So let's go to Azure Data Studio, basic research. And in my expense reports data set, what I have is expense report data and a calendar table, essentially a date dimension. What I've got here is the number of expense reports, the sum of expense report amounts, and the mean expense report amount. So my data over time, I can see that in 2011, the mean expense report was just under $50, and we kind of stayed in that range until roughly 2017. It looks like it went up to 53, 54, 54. Now, in 2012, we did have a higher number as well. So it's looking at this at an extremely high level, I'd say, I don't know. I'm not sure that anything major has changed. But we're going to dive one level deeper. Each of these expense reports was tied to a particular city. So these were salespeople who would travel to cities, they would meet with customers, they would order their meals, and then submit those expenses. I have expense category, which tells you what type of city it was. So we have inexpensive cities, moderately expensive, expensive cities. You know, some places it's going to cost a lot more to get a meal, so we would naturally expect the average cost to be a lot higher. So we have this breakdown, and I'm going to visualize that with the Sand Dance plugin. To do it correctly, I need to zoom out. Let's make this a scatter plot. We're going to say calendar year on the x-axis. We're going to say mean on the y-axis, and we're grouping it by expense category. And what we see is that for inexpensive, there is a level change. So we, up here, we're at mean of 30, 29, 31. Down here, we were at 23, 24. So that's a pretty big shift. It looks like the other two have bounced a little bit, but no major changes. But still, that looks like a real thing. That's going to probably be our area of focus, saying here's the jump. It looks like it happened in 2017 through 2019, and we want to see what the cost of that difference is. And to do that, we'll build some machine learning models. So I'm going to use both R and Python just to show off both languages. So let's build out our R project. If I have RStudio and I have R tools, then I can go File, New Project, New Directory, R Package, and I'll get a screen that looks like this. I'll be able to call this something like Expense Reports R. So I have my new project, and I can create my code. I can draw everything out, go to the Build menu, go to More, build either a source package or a binary package. If I build the binary package, then it'll only work on the same operating system. So let's say I have Windows desktops and I have Windows SQL Server. I could build a binary package on my Windows desktop. It'll work on SQL Server. But if I have SQL Server on Linux, this binary won't work. So I could build a source package instead, and that way it'll work on Windows or Linux. Also, it'll allow my data scientists to build this on Windows or Linux. So source package is typically the way to go. For Python, if we're using something like PyCharm, we can build out a new project, get our virtual environment situation figured out, build our code, and we can build out a wheel file as a result. So new Python package, fill in everything that we need to do, and get that wheel. I'm gonna skip the Python part for today. We'll write Python code a different way. So I want to show you both ways to do this, both our Python as well as the packaged product, and essentially dropping your machine learning code in the stored procedure, just to give you a feel for the differences. So I want to train a model. And in R, we have a function called train model. This function will take in an input called input data set, as well as a string called model type. And model type here will either be linear or XGBoost. And based off of that model type, we're going to build a model using this input data set as our feature set. By the way, if you don't give me one of those two, I'll give you back an error. So let's say this is a linear model. Well, I come up here and train linear model. I believe that the amount spent is related to the year and the category of my input data set. So I'm going to build out a linear regression model and base it off of that. With XGBoost, boosted decision trees, I'm going to load in XGBoost and the data table packages. So bring those in only if we need them. And then I'll say my label is the amount. So the thing I want to predict is the amount. And the rest of my inputs, all of my inputs here need to be in as a matrix. So I take that input data set, I get the expense year and expense category ID, build out a matrix of those values, and run XGBoost against it. My objective is a linear regression. So I've built in, I've thrown in some values, no real optimization in this case, just to give you an idea of, hey, here's how I can do this. When I build out my model, what I'm going to do is I will serialize that model and convert it to raw, to binary, and that'll be called trained model, and I'm going to output that trained model. So let's see what this looks like on the SQL side. Actually, before I get there, if I come over here to build, I say more, this is where I can build source or binary packages. So I could say build a source package. I've installed DevTools already. It's going to gripe at me a little bit and say, hey, here's our tools. But essentially, okay, here is your resulting package. So it's in developing machine learning services, packages, expense reports. So I could go here and I have the latest version that was from today, from just now. So I'll be able to take that package and I could use sqlmlutils to deploy that out to my SQL Server instance. I already have a version out there, so we won't waste the time doing that. Come back to Azure Data Studio and expense reports. I'm going to create a table called model. Model has a language, a type, a var binary max, and is native scored. All right. One thing that I think makes database administrators a little iffy about this is I'm recommending storing the models in the database itself. Now, go back to the old days where people would store images in the database. That's a bad idea. And so I can understand why DBAs can get squeamish about this. That, wait a minute, you're having me store these models. I don't know how big they are. I don't know how frequently they're changing. This just doesn't feel like the thing that I want to store in a relational database. And generally, I'm very sympathetic to that argument. But there are a couple of reasons why I would want to store the model in here. Reason number one is if we are using native scoring, I need a way to get to that model without using R or Python. The model has to be stored someplace where I can easily access it within a stored procedure or within T-SQL, just general T-SQL code. So easiest way to do that is, frankly, if it's in a table. The second reason is we actually talked about that a little bit with SQL Server 2019. The security model has changed to where by default, R and Python can only look within one temp directory. So if I have my model stored on disk someplace, I can't get to it unless I explicitly grant rights to access that location. So this is actually a bit more secure of a process. The third thing that I would point out is that for the most part, these models tend to be pretty small, and I can use the compress function and the uncompress function as of SQL Server 2016 to perform gzip compression of the models. So if the thing is a little big, I can gzip compress it. It's already var binary, so all I have to remember to do is uncompress it, and we get to take advantage of that gzipping. Some of the models are pretty text heavy and verbose to the point where we were generating models per product. Basically, we have somewhere around 10 million products that we've generated predictions for our actual production project. Some of those models were using one algorithm which would generate a roughly 1 megabyte model. So that's pretty big. Gzip compressed it, it was down to about 40 or 50K. There was a huge amount of duplication. There's a huge amount of text bloat. Gzip compression got it down to much smaller. So if you are concerned about size of the model, gzip compression can work here. But otherwise, we'll see. I'll give you a quick idea of how big these models get, but usually it's not that big. It's usually not even 1 megabyte. So, all right, we'll create the table. And I'll have a stored procedure to train a model. We take in a language, a model type, and we are going to output our trained model. I'm going to in here declare SQL and a remote command. So this is my T-SQL query that will generate my data for training. And we're going to query expense report, joined to expense category, joined to employee for dates prior to 2017-01-01. So that'll give us our training data. If the language is R, I'm going to set the remote command looking one way. If it's Python, I'm going to set it a different way. So that's why I'm using this remote command variable. If it's an R, we're going to load that expense reports R package and run train model, passing in the expense data, which will be the result set from this, and whatever model type I send in. So whatever model type I pass into the stored procedure. And then I set that by replacing what's currently in here. That way it looks a little prettier. If it's Python, this is the other way. My general recommendation is try as much as possible to look like this, where I have 1 or 2 lines of code, and that's it. Try not to have a lot of R or Python code in here because it's hard to debug, it's hard to write, it's easy to mess up, and your data science team isn't used to this interface. They're used to PyCharm or RStudio, so they're going to prefer to be over there. Nonetheless, this was a few lines of code, and I wanted to show you, this is what it looks like when you don't build out your own project. So we load Pickle, we import a random forest regressor and create it here, and then I'm going to fit my random forest regressor. I'm going to pass in the expense category ID and expense year as my features that I want to, my independent variables essentially. And I'm going to use expense data.amount, .values.ravel, as the label. So this is the thing I want to predict. This is what I'll give you in order to predict it. And we generate that remote command. SP execute external script will run for the language that we selected, run the remote command we've generated, pass in the SQL command to execute, call that expense data. So we call it expense data here. That's why in Python, I said expense data. And in R, I'm passing in expense data here. When we get to the R package, I call it input data set. So I have that, essentially the name changes, but that's okay. So we pass in expense data, and I'm expecting to get back a var binary max output. I'm expecting to get back a trained model. So here, trained model is the serialized version of this model. For the R code, we serialized it, converted it to raw, and deployed it. And I did want to mention that I have a variable called trained model with no underscore. I have a variable called trained model with an underscore. Yes, this will work. I wanted to show you that it works, but I also wanted to say, you know, in practice, this gets really annoying. So it's nice to have everything be standardized. But if for some reason you had some sort of name mismatch, we can handle it. So Ronan says, if you have data which fits an unstructured data type that you want to analyze, you can leverage SQL Server to read Azure Data Lake storage files using Azure Serverless Synapse SQL pools as a bridge between the server and the Azure Data Lake storage. Yes, you can definitely do that. This will provide you awesome performance, but will cost some money. Yeah, that'll work fine. You could also use Polybase and connect to the Azure Blob Storage endpoint for that data lake store, and that'll also work well if you have a proper structure to that data. So Azure Serverless Synapse SQL pools, or the on-demand SQL pools, pretty solid options. All right, let's execute this procedure. I want to show you that it works like we would expect it to. So I have a trained model. I'm going to say Python, run the random forest regression, and show me what the model looks like. There we go. And it gives me back a whole mess of binary. I have no idea what any of this means, but that's our model. That's our model serialized to binary. And I can take that and I can store it someplace. So that's what this second procedure is all about. So this one, expense reports train model. This is a pattern that I like to follow personally. So I have the ML model. That ML model is where I have the interface between SQL Server and machine learning services. That's where I have all of this internals stuff. And I can easily execute that ML model as a stored procedure call. Then this procedure, this wrapper procedure, is where I write to disk. It's where I do any additional work following up from it. If I need to troubleshoot my machine learning services portion, I can easily run this procedure without it affecting any data downstream. If I run this procedure, then it's going to insert a row into dbo.model. So I like having them be separate procedures for that reason. So I'll have train model, language and model type, and that just calls the train model here and inserts the results into dbo.model. So I'll create that procedure. Yarif says, so the process is like saving and loading a graph in TensorFlow. You can create a graph schema, save it, and when you want to use it, you load it and fill it with data. Is that correct? That is absolutely correct. And we're gonna see just how correct that is. Truncate dbo.model, and I will run this for all three of my models. So R with my linear regression, R with XGBoost, Python with random forest regression. I chose all three of these because they are fast. They don't require a lot of processing power, definitely don't require GPU. That way you can run them locally. You can follow along. It'll probably even be faster than when I'm running it if you were to run it. I will eventually get my results and I will be able to query dbo.model. And actually, I think I have my results now. Yep, good. So let's query dbo.model. What we see is my three models, and we can see that the linear model is 204 kilobytes. The other two are 30 kilobytes. If I were to compress them, they would actually get even smaller than that. So if I do something like this, 204K down to 32K, and then now we're talking 5K and 9K. So those would be very small. I would just need to remember to uncompress when I use them. So speaking of using them, we want to generate predictions. I'm going to create or alter procedure, generate predictions ML. Given a language, given a model type, we are going to score some data. The data that I want to score is everything after January 1 of 2017. So otherwise, same data set. By the way, I do want to point out that amount I have labeled as a decimal data type. Machine learning services, when querying Python, when going out to Python, does not support decimal. So I have to convert this to a float. The R code will support decimal, but Python will not. So I find from dbo.model for language type and model type, give me back the model. Then for R, I'm going to call generate predictions, and I'll send in my data set, my model type, and the trained model itself. So let's go look at RStudio. Here's generate predictions. It takes in an input data set, a model type, and a serialized model. We check to see if the model type is one of our two appropriate types. Otherwise, we give an error. If it's a linear model, we'll generate linear predictions. For XGBoost, we'll generate XGBoost predictions. So let's generate linear predictions. Given our inputs and the model itself, I need to unserialize the model. Then I'll run predict using the new input data set. So it knows, because it's the same shape of the data, I have the same inputs and I have the same label, it'll know how to transform this data and get back my results. So that'll give me back a set of predictions, the actual predicted amount for a set of inputs. XGBoost behaves similarly. I need to create a matrix of my data. So I need to perform the same setup steps that I did for training, and then I call the predict function to get my results. I'll take my input data set and combine it with, I'll column bind, so I'll combine it with my predictions. That way I'll get back one result set that has all of my inputs plus this prediction. That's what the generate predictions function does. For Python, we load the trained model and essentially deserialize it here. 5 minutes, thank you. My data frame takes the amount prediction. I'll predict based off of my inputs, expense category and year, and then concatenate those two together vertically. So again, all of my inputs combined with my prediction. Results show out as a result set. So I can specify what the results look like. Here are all of the names and data types. And I have a function which will, in this case, my other procedure will essentially put them into a temp table and query the temp table, do some aggregation. I could do more stuff like, for example, load it into another table, save it permanently someplace, or perform other analyses and checks. But we're going to keep it fairly simple for today. So I run this, and it's going to generate my predictions for XGBoost. And what I'll see, let me show you what we're going to see. We're going to get back some results. Expense category, the person, the category, the number of reports, how much they spent, how much we predicted they would spend, and then two measures of difference, MAE and MAPE. So MAE is the mean absolute error. Basically, we figure out prediction minus amount, get the absolute value of that, and we divide it by the number of incidents. So if I have say I'm off by $10 here over the course of 100 predictions, my MAE is 10 cents. I'm off by 10 cents per prediction. MAPE is what percent am I off in my predictions? So MAE is in the same order as, it's like the same denominator as my total and prediction. So in this case, it's dollars. So here, for expensive cities, Barrett is off, we're off by $14 per expense report on average, or 15% on average. As I scroll through here, we're off by a fair amount for everybody. So this is not a very good result. It means I have not defined the model very well. I might have chosen a bad algorithm. I might not have tuned those hyperparameters correctly, but I don't know that any of these results are really good. So we're going to try the linear model. And trying the linear model, as well as the Python random forest regression. Both of these are going to give me back essentially the same results. So for time's sake, we'll just point out here, okay, you're off by $4 on average. That's about 4 percentage points difference. 88 cents, 3%, 2%, negative 2%. So in a lot of these cases, we're off by 0 to 3%. And then we see a person here, like Ebenezer Graham, you're off by 39%. And then you're off by 8% on moderately expensive cities. So we're close to zero, kind of bouncing around, sometimes above, sometimes below. And then 39% for Molly Hart. And then 8% for her in moderately expensive. So what we're finding here is these were the people who had issues. And for the most part, this model is pretty close to the correct number. Sometimes we're a little above, sometimes we're a little below, but generally we're pretty close, except for the occasional person who's way off. And these are the people we can see. And we can also see that although we couldn't really spot it with our eyes looking at this, really not easy to tell that there was an increase here. but it turns out there actually was. It turns out that for some of these people, they were going up to $40 and moderately expensive when they might normally have been, say, $35. So we get to see the rough order of how far off they were, how much we expect that they were actually gaming the system. So we've seen deploying custom code and wrapping up. Machine Learning Services gives us this ability to operationalize R and Python code in a way that I think is pretty effective. It can help you bring machine learning models to production. I've put it out in several projects. I've got it running right now in production. If you'd like to learn more, I need to fix this link. It will be csmore.info/on/mlservicesdev. These are brand new slides for me. I had to revamp everything, so I've got a couple of slide bugs. Let me double check that that's the right link, and if so, I will paste it into chat. Yep, there we go. That is the correct link. If you do have questions afterwards, please do feel free to follow up with me, email address, Twitter handle, and I'm also available for consulting as well. So with that, are there any additional questions in chat? If so, drop them in, and if regardless, hope you had an enjoyable time with this.
Absolutely. Any questions, people?
Thanks, Kevin.
Well, thank you very much, Kevin. This was a lot of stuff in 1 hour. It was really interesting. And again, thanks for your contribution to the community.
Thanks. I appreciate the opportunity.
Excellent. So this will be recorded and uploaded to the meetup as usual, and I will also post all the links that Kevin provided, so you can find them there as well. Thank you very much, and we'll be in touch. Bye.